Sometimes the leading coefficient does not factor out. In the case you see here, the greatest common factor of 3, 11, and 10 is 1. So we're left with a leading coefficient. So instead of finding two numbers whose product is 10 and sum is negative 11, we actually have to find two numbers whose product is 30. 3 times 10. So we're looking at a product of 30. Now you can sort of see how this works out if you will follow the logical steps here. You see that 6 times 5 gives us 30, not 10. The difference is 11. The sum of the differences is 11. So we have our 11 x's, but you notice 6 times 5 is 10, is 30, not 10. So, and then if you follow it backwards, you'll see why that works. So instead of just going for the 10, if you have a coefficient on x squared that is not 1, then you have to take the product of the leading coefficient and the constant to factor. So here we go. Now, first example here, we have a 30, 110, and 100. We can factor out 10 and we get this simplified expression here. So here my leading coefficient is 3, constant is 10, so I will factor 3 times 10, which is 30. And then over here I see that my two factors that will give me 11, both negative, are the 5 and the 6. Then we exchange the 11 x's with 5 x's and 6 x's. We're going to hold on to that 10 until later. We're just going to work with these three terms, replacing the 11x with 5 and 6. They're both negative since the product has to be a positive 30. So here we see that we can group the first two and the last two terms. And finally we factor out the greatest common factor from each pair of terms. And then we recombine the 2 and the x into x minus 2, both multiplied on 3x minus 5. And don't forget the 10 we factored out in the beginning. In our next example, we can see there's nothing to factor out from the beginning. So we will focus our energies on finding two numbers whose product is 5 times 12, or 60, but whose sum is 17. So as we look at the different possibilities here, now wait a minute, this 60 has to be negative because of that right there. It has to be a negative. So let's see, a negative times a positive to give us the negative 60. That means one of these numbers must be negative and one must be positive. So looking at 20 and 3, if 20 is positive and 3 is negative, I will get 17. So those are the two factors I need. So 3 will be negative and the 20 will be positive. Then I group the first two terms and the last two terms and pull out the greatest common factor. The first two, the greatest common factor is x. Second two, the greatest common factor is 4. So then I have x times 5x minus 3, and I have 4 times 5x minus 3. X times 5x minus 3 and 4 times 5x minus 3. So I'm finished. On this particular trinomial, 2 is the greatest common factor, so I would pull out the 2, factor out the 2 first, and then I'm left with this simpler trinomial. Since my leading coefficient is not 1, it's 7, I have to take the product of 7 and 6, and 6 is negative, so it's going to be a negative product. That means one of these factors has to be negative. And we're looking for the 2 factors that will give us, we need minus 1 in the middle. So these 2, 6 and 7, if 7 is negative, 6 times negative 7 will give me the 42 I needed, but it'll also give me a minus 1 when I add them. So positive 6, negative 7 are my x coefficients. I factor out the greatest common factor from each pair of terms. 7x times x minus 1 will give me this, factoring out a 6 from these 2 terms. Then I have my common factor here, which is multiplied by 7x and by 6. Don't forget, we did divide off the common factor of 2 in the beginning, so that needs to be in place before we call it finished. Here's another one, and you should try it as well. What you can do when you get your final answer is enter both in the calculator. They should graph on top of each other, and then you'll know you have an equivalent. The other thing to check too, and I didn't point that out back here, is look and make sure that there is nothing in common in each of these parentheses, because if you say forgot to factor out 2, this would be 14x plus 6 if you hadn't factored it out up here. And so you would have a common factor, and you need to check that, make sure that that is factored out. Other than that, you can put this in your grapher and graph it on top of your original expression. Put both in there. They should graph on top of each other. There should be one parabola on top of the other. Then you know you have factored correctly.